Revenge of Planet of the Ass Clowns, Take 4. Okay, Bray. Hello, I'm Jack Rickard with EVTV. This is my compadre and consigliere, Brano Noto.
Good to be here.
It's Friday, Brano.
Well, only in your alternate dimension is it Friday, Jack.
I thought it was Friday all day. I put off shooting till today when Brain wanted to shoot yesterday. The matter of confusion was he thought yesterday was Friday. Actually, it was Friday.
It was Friday. You know,
we're here on Saturday. We've been working all day, and they finally told me that today is Saturday.
Yep. We threw the tennis ball in with the rope to suck him out before he looked at the light, but we were too late.
The nice thing about Alzheimer's is you get to meet so many new people every day. And who'd you bring me?
That's right. Well, we brought Christopher. He's been helping us with the website and everything. Everybody should know him by now.
Uh-huh.
And what did he do? Get out of the Navy or something, or go AWOL? We're not even sure what happened.
Christopher Fisher of somewhere in Florida. Where do you call home in Florida?
St. Petersburg, Florida.
St. Petersburg. And but he's been in the Navy where?
Stationed in Naples, Italy, and Norfolk, Virginia.
Mm-hmm. How long were you in the Navy?
8.5 years.
Okay.
And so Uncle Sam's Yacht Club, after the first 8.5 years, you decided you tried it and you didn't like it.
Yeah, I thought there must be something better out there.
And what's her name?
Her name is Carolyn.
I see. And you all are going to live where?
In Sweden, Stockholm, Sweden, yeah.
Well, good for you. All right.
Yeah, well,
It's all part of God's plan.
That's it.
She'll make you miserable. Anyway, welcome to EVTV. Chris is taking a break and has come and is going to kind of help us get ready for the show. I hardly know where to start today. What do you want to talk about? News first?
Yeah, I guess news. We've been kind of working on the show in the car this week. I've been remiss, and actually I haven't really picked up a lot of news items the last couple of weeks.
You know, I have a couple of interesting things. There isn't really a whole lot going on.
Yeah, there hasn't been too much. Maybe because the show, everybody's quiet.
Yeah, you know, all the online blogs and stuff are sagging pretty badly.
Everything is sagging?
I did see Nikki Gordon Bloomfield. I used to listen to her on some sort of podcast.
Yeah, what was that
with
podcast
a couple of
thing? EVcast?
Yeah, EVcast or something. Now she's with electric vehicles or something. She did a report on the actual expenditures of Nissan to get into the Leaf game. Any guesses?
Oh man, I couldn't imagine.
$5.6 billion.
Oh man. Oh.
You know, I love unobtainium, but I do like to keep tabs on battery chemistry. And there's a real one.
Oh, okay.
A real breakthrough. And that is Trey Cool.
Okay, and we need a breakthrough.
How can I tell the cool ones from the goofy ones? I've been doing it a very long time.
Yeah.
Through several industries. This one's cool.
Okay.
The way a lithium-ion battery works, and I'm going to do a whole session on this in convention.
Okay.
But let's talk about the anode side. A lithium atom intercalates with a carbon structure in the anode side.
Okay.
Lithium is very good about, it has a single electron in an outer valence band that's very weakly bound to the lithium atom. That's why it's so reactive. It'll give this electron up very readily, but it does want it back.
Yeah.
If it can get it.
If it can get it, sure.
So in charging the battery, and bringing it to full charge, what you basically do is attract the lithium atoms to the carbon side, the copper foil negative side of the cell. By pushing these electrons onto the plate in the charge process, that lets these bind this way. The lithium ion intercalates with the carbon. And that's because the carbon is actually a crystalline structure. This is not like making a new element. It's not like mixing things. It's a conversion of a crystalline structure. And the insertion of the lithium ion into that structure is called intercalation.
Okay.
And the extraction of it is deintercalation. The problem is this is not a new element or a new molecule. This is a crystalline structure where they're actually sort of sharing electrons. The anode of our cells, lithium iron phosphate cells, is carbon. Now, they would like you to believe that this is magic carbon, nano powder carbon, or something like that. Do you know what it really is?
No.
Coconut shells.
Oh, that's right. They burn up coconut shells.
They take coconut
That's right.
shells.
I do remember that.
And,
yeah.
and they cook them, and then they extract all the moisture out of them and grind them up very small. Activated carbon. It's the same thing using your Brita water filter.
Right. Right. Fish
It's about the
tanks.
same grade.
Yeah.
But they get it to adhere to the foil with a binder. It's called polyvinylidene fluoride, or PVDF.
Okay.
And that's the binder. And they, it's like a plastic, a polymer. And first they have to make it into a liquid using a solvent called NMP. And they make this up into a slurry and literally run this foil through this slurry and then kind of cook it and dry it out to where it adheres to the foil. The foil is the current collector. The carbon is the actual anode.
Okay. Yeah.
And it forms a crystalline structure. Each time you intercalate or deintercalate, when you intercalate it, it swells. And when you deintercalate, it shrinks.
Contracts. Okay.
Well, that breaks it.
Okay. So breaks the crystalline structure a little?
Right.
Okay. Okay.
So over time, this is a cumulative amount of damage.
Right. Just a little bit at a time. Yeah.
Now, there's another thing that happens with the electrolyte, where you can form kind of what they call an SEI barrier. It's a reaction at the surface of it that if they do this just right when they're forming the battery, it actually sort of glues it all together.
Okay.
And so we can get 2,000 or 3,000 cycles out of the battery. There is another material that is much better than carbon for the anode of a lithium ionic cell. And it's very interesting because it's totally inert. It's so cheap it's almost free. It's one of the most abundant things on the planet. And it's 8 times more powerful at this intercalation and deintercalation of lithium ions than carbon is. We refer to it as silicon. You may know it as sand. It's really cool. It's what you make glass out of. It's one of the coolest materials in the world. All photovoltaic cells are made out of this. All of our electronics are made out of it. Everything is silicon based. The problem is when you intercalate with silicon, it expands by a factor of 4 because it has 8 times more lithium ions in this. Basically, our cathode is an olivine structure, but I think both silicon and carbon are kind of more of a cubic structure of a crystal. But it will do about 8 times more lithium ions in the same crystalline structure. It has more corners, assume. Okay? There are more attachment points where it can share an electron and intercalate this lithium ion into the crystalline structure. But because it can add more, it swells more. And it breaks the silicon faster. So you can't really use silicon. team at Georgia Tech and Clemson. Georgia Tech Material Science Department for Energy Storage has been looking for a new binder. And because it has to be inert to electrolyte, they decided to look at the aquatic plant kingdom for a polymer because they have to live in seawater. Mm-hmm. They have to be resistant to essentially a global electrolyte.
Right.
They came down on a brown algae, basically kelp.
Abundant also.
So instead of using seashells, we should use kelp.
Well, it's renewable.
And renewable.
Yeah.
Let's see, how did they do that? They basically boil kelp in soda water.
Really?
Mm-hmm. And that gives them a substance called alginate. And alginate is actually what's most commonly used in foods for gelatin, where they used to use cow knees and hooves and stuff. Alginate is what has emerged as being the gelatin and jello and that sort of thing.
Yeah, you see these guys use it too, this molecular gastronomy. These guys making foams and stuff, they use alginate. Yeah.
This is a very common gelatinizer for foods.
Yeah.
And dirt cheap.
Yeah, I bet. Yeah.
So better, it can be dissolved in water instead of the NMP solvent. And so they are investigating the use of alginate in kind of a higher proportion, where the silicon is in a greater amount of polymer, in this case alginate, as the binder. And water's all that has to dry off to bind very small nanoscale silicon particles to the copper foil using this alginate.
Interesting. Yeah.
As the binder.
Yeah.
And it potentially could dramatically improve the cells. Now, to take advantage of that ability to do 8 times the energy capacity in the anode, you kind of have to do it on the cathode side too. And we haven't got all that worked out. Yeah. But it would, as it is, improve the capacity of the cells probably 30 or 40% with the existing anodes.
Okay. Wow. That's still a big change.
And that's a big chunk of change.
That's a big deal, yeah.
It has the potential to even improve the cycle life of our existing cells using the carbon.
Just the binder.
And the change,
wow.
They don't even have to change their machinery. It's water instead of NMP and this alginate instead of the polyvinyl fluoride as the binder. And this is like, you would have to spend all weekend changing over the process.
Yeah, cleaning the hoses out and stuff. Yeah, changing the barrels.
This is really a neat deal.
Absolutely.
And I would, unless something heroically wrong with this alginate shows up, I don't see anybody making a battery with polyvinyl fluoride binder 12 months from now.
Yeah, that wouldn't make any sense at all.
It just is almost nonsense. Yeah. And so it's kind of an interesting breakthrough in battery chemistry. We had another announcement this week. I got an email from our buddy Sebastian Bourgeois. Bourgeois? Bourgeois. With Evnetics. And he's down in, coincidentally, Tampa or St. Petersburg down there somewhere, isn't he?
St. Petersburg, yeah.
And he has notified me that, and I had talked to him about this several times, that they have decided to develop the monster DC chopper of all time. They're going to do a controller. I think he calls it the Evnetics Soliton Competition Controller. Or maybe the Soliton
He did give it a different
racing
name.
control.
Racing, yeah, something.
But they're
yeah.
going to do an initial run of 25 of them, and it's primarily aimed at the racing community, and you'll see why when I tell you. It's $7,500, but it does 3,000 amps peak and 2,500 continuous. That's not a misprint, continuous
wow.
amperes at up to 3,600, 360 volts. That, my friends, at 3,000 is a megawatt.
Megawatt, yeah.
We're trying to get 250 kilowatts into the
The Cobra. Cobra, yeah.
This would be a controller capable of doing 1 megawatt of broadcast power.
Capable of powering a small
Send
city.
your cards and letters to Jesus. That's JESUS, Cara del Rio, Texas. 1 megawatt of it, strictly illegal.
Be there.
AM radio power.
We've all got our AM radio voices on.
Now, Chris, you were telling me briefly, but I'd like to know more, that you had, on your way, of course, you went home, saw your family. They're all good.
Yeah, doing good.
And then you stopped to see Seb and Etics.
Yes, I did.
And I'm fascinated with the tale you returned with. What did you see?
Well, I got a quick and brief tour of his facility, and then talked with him and Jeffrey Jenkins for a couple hours actually. And what I was stunned by is that they literally manufacture everything in-house. All of the circuit boards, they have all of the machines to do the CNC machining for the housings, and they make all of their plastic materials there. I mean,
wow.
Everything is 100% in-house. It's all controlled, tested, managed, quality control. I mean, it's
vertical integration. He was describing quite a process on their PC board, and in fact, Sebastian had mentioned they have a new guy from the aerospace industry, really, in there, sort of doing
Yeah,
the
that's what you're
QC
saying,
on their
yeah.
circuit board development. And how did they make their circuit boards?
They have a surface mount circuit board machine.
A pick and place?
Yes.
Oh, wow.
And they put it in the machine.
That's
and
pretty cool.
It just goes and grabs them and drops them, and they put them through an oven, and that will solder them to the board, and then they do their QC.
Wow.
I'm not sure what their production rate is, but it's
He
pretty
was
efficient.
saying
Amazing. Yeah.
they have a new machine, part of it, you've seen the case. A lot of times things like the enclosures are what's hard. The cobbling together the electronic components is not such a big deal, but mounting them in an attractive enclosure that's sturdy, that handles the thermal issues and so on. So they've got this, they actually machine this billet aluminum, I guess, enclosure on an automated machine that can now do 4 or 5 of these a day.
Huh.
Yeah, it runs 24 hours a day, 7 days a week practically.
That's pretty cool.
And so and this is so important. Most of these guys, cottage industry type thing, are cobbling these things together by hand, or getting the circuit boards done by Sunstone or something, but then they still have to cobble it together by hand. And so to have that sort of 3D CNC capability, and to be able to do designs on the computer and have them machined out in plastic, or, you know, I'd love to do that. It's just, we'd have to stop what we're doing and do that.
Do that, 100%. Yeah.
We've had a guy in here showing us a 3D printer. I was just enthralled.
That's all we do, though. Yeah.
But I would just sit around and play with that all day, and we'd never do another electric car.
He was very proud of the fact that he doesn't send any of his work to China for manufacturing, and you don't have any delays in that respect. And
No, rightly so. It's to
if
be able to produce
the process,
100% control.
100% control of the process, and of the backlog. See, half the time these guys build the demand for the product and then can't meet it.
Right.
And then by the time they can, I mean, we watched the Zilla go through the death throes for 3 years. They're in the floor thrashing around. I'm like, somebody drive a silver stake through the heart of this beast. Put it out of its misery, for criminy.
It's still that flagship product that everybody wants to throw out there. You know.
Well,
Use
with
the
the
Zilla.
advent of a 3,000 amp controller, I would say that's the end of that is the silver stake. Because the Zilla 2K was just a lot bigger controller than you could get. For
He
anything
still
else.
has 2Ks left from the original runs.
I still have one in my garage.
Yeah.
I can't do anything about it because our viewers can't get them, and so I'm completely disinterested in them. There's rumors of Rich and Manzanita and that, but who knows?
We really can't tell yet. Yeah.
It's on the web,
Right.
That they have them. I don't. Has anyone bought one recently? Have you?
Haven't heard
know
of
of
it,
anyone
no.
receiving a Zilla?
No.
So
That package is an older package. It's not as attractive as the Soliton.
Oh no,
All-in-one
not in any way. In fact,
can-
with that hairball and stuff, it's a nightmare to put together by comparison. This Soliton announcement's very cool.
That's
We're
really cool.
we're very taken with the 1400 amp Warp-Drive, and then now this Soliton. Who's going to use a 3000 amp controller?
Just racers, yeah.
Exactly. But it puts that
It moves it in,
imprimatur.
right.
This is the old race on Sunday, sell on Monday thing. They will sell a, what's my engineering technical term, a shit pot full of Soliton Juniors based on the fact that there's 25 Soliton
big boys out
competition
there, yeah.
models on the strip.
yeah.
So that's no prediction there. That's a marketing thing in automobiles for 100 years.
Yeah.
But it gives you flexibility. I mean, you don't have to run 3,000 amps. You could run 2,000 amps, like in the Cobra or something like that.
They also, somebody told me when Seb come up here that he's the EV whisperer. And you were saying that he hates every EV he's ever made.
He does. He was his first thing he said to me. He said, "Well, why are you here?" I said, "Well, I want to check a place out and meet you and see what you do, and maybe start conversions." And he said, "Oh, that's not good. That's not good." He said, "Well, everything I'm going to tell you is all to dissuade you from actually
sells
doing them."
controllers. Why would he want to dissuade somebody from doing
don't know.
conversions?
Well, he said he loses. He has lost so far megabucks in every conversion. He pays people to drive away in their cars.
We have done one for other people, the Cobra, and that will be the case.
Yeah, absolutely.
We get to buy part of their car.
That's rough.
Yeah.
We'll have to go to
It's,
Taiwan and visit it.
I think the way to do it is you pick you out a car and you'll make that car for somebody. And if they want a different car, they can go to anybody else that does
Get
that.
a different one, yeah. Does that one, yeah.
We do like Speedsters and maybe Mini Coopers. Mini's got a new coupe.
Yeah, they do.
There aren't any on eBay yet, but they
Yeah.
do have a Mini Coupe,
Yeah.
and it's got an interesting amount of space in the back.
Yeah.
And it's smaller and lighter
Small, yeah,
and stuff. We got very ambitious with that Mini Cooper, and I like it. But I'm thinking, what would that be like with a AC50 and a Curtis 1238?
Yeah,
It'd
just
be a
bring
little
it- bring it
underpowered,
back.
but I got 6 gears.
Yeah.
Yeah, just bring it down to earth a little bit, the conversion, yeah.
And get that thing to sing a little would be cool. So that's that. We have made some progress on the Cobra this week.
We have.
Let's take a look and see what we've got put together.
Alrighty.
All right, what we have here, finally, but worth the wait, I think.
Yeah, it looks like a great piece.
This is actually pretty cool.
Yeah.
The more I play with it. This is the Netgain Controls Warp-Drive Industrial Controller.
You gotta love it.
Is what they're calling it. Ryan Baum, who has EV Source, and as it turns out, he's doing some work with some government people on magnetic induction charging.
Okay.
He's a pretty capable young guy.
Oh, good. Okay.
And George Hamstra have partnered on this Netgain Controls. We got one a year ago.
We did, yeah.
It used a Prius pedal. This is an anomaly, but I'm coming around to his way of thinking. He wanted a safe throttle, so he chose the Prius pedal, and that's the only one he would support.
Which is tough to mount in some cars.
And was the subject of a recall.
Yes, that's right.
And a number of uncommanded accelerations.
That's right. Just
so
go.
But in any event, what he was striving for and describing was that modern OEM accelerators have 2 return springs, for one thing.
Right.
But they also have 2 outputs, and the outputs are not equal.
Right. They're different voltages, or
they're different voltages.
Okay. Yeah.
This one, his Prius pedal starts at 7.5% of the voltage, and the second Hall effect starts at 15%.
Okay.
And then they both go up from there linearly at different voltages.
They're never the same. Yeah.
Now, what does that give you? Well, you can compare the 2 voltages, and you know the relationship, and there's no way that can be faked with an error.
Right. Okay.
So if they do not match, and by match, they're not equal, they're in relationship to each other, you can determine in your controller whether you have a valid throttle input, or if you've got a problem, with your throttle itself. A throttle is an electromechanical device. In the Navy, when we would troubleshoot things people actually used in combat and so forth, the first thing we did was check wherever human hands could touch.
Right.
Because that mechanical input to make an electrical signal was 99% of the time.
First thing to wear out.
Because it was a wear item.
Right.
And so this is all pretty good thinking.
Good.
They did a version of it. It would only work with their pedal in the cars we were doing at the time. That pedal physically wouldn't go in the car.
Right. No, that Prius pedal is a strange animal. Yeah.
But he's come along some since then. He's had a few of them out of the first version.
Okay.
I've talked to a couple people that have used them. They've been through a couple firmware upgrades, but they like them.
Okay. Yeah.
This one, their industrial model, is that he sent me 360 volts, 1400 amps.
Yeah. You gotta love that.
Nice. That's let me put the magic calculator on it, but that's a half a megawatt, 504,000 watts, 504 kilowatts.
That's amazing.
Of power that this can ostensibly use. His spec is a little disturbing. Let me show you this. Let's spin this around. These are the motor cables that we just installed. They don't come with it. And these are my battery cables. We're putting it in the Cobra. He has upgraded his coolant to A&8.
Those are nice. Those
Sunrise,
fittings.
and I like the black ones even.
Yeah,
and they look nice. Good with his box, with the black blend nuts. But these are A&8 fittings for the coolant. He starts to degrade or reduce current at 55 degrees centigrade or 131 degrees Fahrenheit.
Okay.
And that's a fairly low temperature.
Low. Yeah, fairly
now
low.
It's fairly gradual up to about the 85 centigrade, which is what I'm a little more accustomed to.
Right, okay.
But so this is a fairly aggressive protection of the device. And so we're going to have to move fluid through there and cool it substantially.
And that A&8 should do it,
with the A&8s, but we're going to have to use a Durali heat exchanger.
Right, with a fan.
And a pretty good pump and so forth. But this is the device. I've got the top cover off. Very nice red anodized aluminum with captive screws, seal, he shows this dumping a bucket of water on it. He never does make the claim IP67,
no,
but I think that's what he's shooting for that certification. This is still a beta, so he can't say that until it passes.
Until it passes, yeah.
But he's got 4 LEDs here that are on the board. Caution, high voltage danger, duh. Yes.
Yeah, don't drive with the top off.
You actually have fairly quite substantial metal bars with 8mm cap screws that you make up your cables and put them in and screw them down flat to the bar.
That's nice, yeah. Yeah, that's a lot of surface area, a lot of contact.
It says 2.0 is common on the battery side. Here's a B+ and B-. But you should consider 4/0 for the motor side.
And we just happen to have some laying around.
You know, we did. And so we put it on there. Those are pretty big cables.
A couple of orange snakes coming out of there.
Yeah, they are. 2 connectors for his interface module, which is kind of cool. It's a CAN bus display that you can put on your dash, and it'll give you a lot of the parameters. It's a step up from the Curtis 840.
Okay.
But it'll tell you your current, your voltage, and your RPM, and so on and so forth.
Okay, good.
And
good.
And he does something I like. He uses a standard RJ45 Ethernet connector and an Ethernet cable to connect them. He didn't really supply that, but I know where to get those.
We know where to get those.
Up in my bedroom, there's 10,000 of them, kind of in one big nest.
Yeah, one big ball.
And he's got a nice weatherproof cover that you can put over that to connect it in here to the intelligence. This is a very nice Molex connector.
Oh yeah.
8-pin. And we're going to show you in a bit our low-car pedal. And he actually did me a low-car cable.
That? Oh, he did a cable, yeah.
And he did profile that pedal. He now uses 3 pedals, the low-car among them, and the Prius and another one, and expresses some willingness to work with you on the pedal. But you have to have a pedal that's, you know, an OEM grade.
An automotive grade.
Puts out 2 signals, 2 return springs, or he's not going to fool with it. A nice Molex connector this is just for the throttle input. And the throttle input's a little more advanced than what you're used to. You have 2 5 volts, 2 grounds, 2 outputs, and so forth. Then you get a nice, really.
It's nice. It's made up.
And it's made up. We get a lot of. We get the connector and a sack of pins.
Yeah.
But he's made this up. You'll have to splice to it, perhaps, if these aren't long enough. But
that's nice.
This is your basic connection cable, and pretty basic. 2 orange wires go on either side of the contactor, and that is it does its own pre-charge.
Oh, okay.
And it manages that. It has 3 12-volt inputs, 12-volt unswitch, 12-volt on, and 12-volt start.
Okay.
And it has a brake light and a reverse light input.
Okay.
And that's, you know, kind of the story.
Good.
And then it manages the coil of the contactor.
Yeah.
Which we're going to route through our master cutoff switch to the contactor to do that. And so that's your basic cable. Nice gland nuts.
Yeah, nice piece.
It's
nice.
About 22 inches, you know, to the gland nuts. But you have some radius on your cables that's kind of required.
Yeah.
And your hoses.
And your hoses, yeah.
This looks like an excellent package. It's actually a little awkward. And it's simply because of the length.
It's long, yeah.
The problem is I don't know how to tell him to get well on it. All this stuff is needed kind of where it's at, but it's so long in the car, I can see some real problems. Our motor is not that far from our contactor, a negative thing, but I'm out here 2 feet and have to swoop around and come back to the motor.
Get the motor, yeah.
Now, if I put this up close to the motor, I've got to come around with my battery cables.
Yeah.
And then here's my cooling system out here. And so I don't know, I mean, it's a gorgeous package. it's just slightly awkward to deal with. You do have to make up your own cables, and as I said, 8mm cap screws. They bolt right down onto these plates very securely. Very nice IP67. We use a little hydraulic crimper, and you've got different dies that can go in that. This is a 50mm die we use for the 2.0, and I've got a 70mm die in here for the 4-aught crimping, and you have to have the right size terminals for that. And but we've got that put together. We have put together a plate kind of mounted from the transmission up to that square plate on the front of the motor, to mount this on, and we'll show you that and the low car pedal here in a bit, how we're mounting this. But this is a you know, I've got great hopes for this controller.
I like it.
The quality of the build is excellent.
Yeah, very nice.
His pricing, I don't remember what it was, $30-something hundred probably for the top of the line, 1400 amp, 360 volts. You can get this in different voltages and current levels all the way up. It's the same package, and this CAN bus lets you do the firmware updates very easily.
Right.
And
Good
so
deal. Nice.
the setup on this, he's really trying to make it super simple.
Okay.
For example, we don't calibrate the pedal. Again, he does.
He's already done it.
Well, I hope he did a good
hope he
job,
did,
because we have few in the way of options there. And there are some things you can set with the interface module. Let me pull that. This kind of, it comes with a suction mount onto the windshield, which is one of the few I've ever seen that actually kind of works.
It actually
got a little plunger there. It sucks, yeah.
All right, it sucks.
All windshield suction mounts suck.
Yeah.
But this one...
That one really sucks.
This one really sucks. It sucks enough that it's probably okay.
That it might work.
That it might work. But this is the Warp-Drive interface module. It is optional. You don't have to use it, but it's it gives you a display and some controls to set some parameters.
Yeah, nice.
And I went through his documentation last night, which in the case of the Warp-Drive Industrial controller is somewhat preliminary. It's actually quite clear.
Good.
He actually has done a good job of describing the product and the process of installing it, and there's clearly a lot of thought has gone into this to simplify the installer's work
and the setup,
and what they have to do. A very high quality package, and it kind of remains to be seen if we can get this to squirt
some
electricity
juice, some amps
into that motor. It could be pretty cool, but I'm very impressed. The initial introduction at the dance is extremely positive.
It looks pretty good, yeah. A nice blind date, huh?
She's pretty.
That's right.
Now, if she just doesn't speak or do anything, maybe we'll leave it at that.
Right.
But no, it
looks good. Yeah,
it's a nice little package, and again, I always drop screws. These are pretty small, but they fit right on there. You do have to remove the lid, but beyond that, here's a kind of a circuit board guard. You're not supposed to go beyond that. There's nothing in there you can do. IGBTs, of course, and but with a good bit of thought given to the cooling, and so I hope we can get maximum power out of this.
Yeah,
with
a
good cooling system. And again, you know, I kind of went this way because of the symmetry of it all. The 11 HV, I feel like I discovered it. George describes it so badly.
Yeah, that's right. He's had it all along.
I feel like I discovered the 11 HV on the bottom of an ocean somewhere, dug it out,
and back in the basement. That's right.
And no, there's guys in the drag racing community out there using it.
Yeah.
But it's kind of a secret.
It is. Yeah. Yeah.
And so the combination of their brand new, still really in beta, 1400 amp controller that will do high voltage, and is also red.
Yes, pretty good.
And they are two different companies, really.
Yeah.
Netgain Motors and Netgain Controls, but I think it's a good package, and I wanted to give it a try.
Yeah, I think so. I think
and
good.
I assure you,
Nice
we are the first with their industrial.
Okay.
This is the first one out.
Okay, great. Good deal.
And so we'll run this with the 11 HV and see what happens.
All right.
This episode of EVTV is brought to you by the Winston Battery Company Limited, makers of high-capacity lithium yttrium rare earth cells, including the popular 160 amp-hour model featuring cycle lives in excess of 5,000 cycles when discharged to 70%, the longest useful working life of any available battery of any chemistry. A leading battery technology scientist, inventor, and entrepreneur since 1995, Mr. Winston Chung envisions a new world of clean electric power for the dawn of a new era of electric vehicles. For your next electric vehicle design project, contact Winston Battery Limited. Energy for a bright future.
All right, so we've got a new project now going on with the Cobra. When we got it from B&B Manufacturing out in Granby, it had, I think, a 427 ring and pinion in it, something fairly low. I don't remember what it is. These are Fords. I'm usually a Volkswagen guy. And as you'll be able to see that soon, because I'm going to need some help putting this together. But this is the center section for a Ford 9-inch rear end. And we understand, now we haven't pulled it out yet, we understand that this aluminum one is going to be a lot lighter than the all cast steel, basically, that we have in there right now. We're trying to get maybe 50, 60, maybe 80 pounds, we don't know, worth of weight out of that rear end. So we went to PPM Racing Products at ppmracingproducts.com, and they're at Tennessee, I think, yeah, Rockwood, Tennessee. And we talked to Ron Hamby, and they do this for a lot of different race cars, a lot of circle track cars mostly. But we are going to swap out our center section, the stock steel one, cast one, for an aluminum center section. He did what he calls the Daytona version of this center section. So we've got our aluminum housing. We've got in the Daytona, he lightens the ring and pinion. One of the reasons that we got in here also was to change the ring and pinion to a 388, which is what we use in, we have used in the VWs. Dwayne Ball did. We used some 344 ring and pinion, but we needed to do it anyway. So Ron put this together, again, the Daytona version, which is polished and lightened. The ring and pinion's lightened. The shaft is lightened. We've got an aluminum short yoke in this little guy. We've got low drag, low friction bearings in here. And you can see this is kind of a beefy setup. Our axles go on both ends here. And you can see the holes that the axles locate in. He's got a retainer right here so this doesn't all come flying apart. It looks like a really nice build. We got this for $1,199. This gives us basically limited slip, gives us everything that we need, short yoke. Once this is installed, we'll be able to determine our drive shaft length. Right now we were at 11 3/4 if we kept the stock one in. We think we're going to be a little bit longer than that, so we'll get a balanced light shaft. I don't know if we're going to get aluminum or not yet, but you know, with a 12-inch run, that shouldn't be that bad. But if you need anything like this, Ron at PPM Racing Products, ppmracingproducts.com in Rockwood, Tennessee, happy to take care of you. The pricing is pretty good too. I mean, we had bought a Quaife differential that we never used in the Mini Cooper, I think, and spent $1,800 just for the differential. So the domestic car market and the high performance products are a lot more reasonable than for a lot of the European cars, as we're finding out. So you can do a lot of work to the car, and we'll rotate that for you. You can do a lot of work to the car, lighten things with off-the-shelf products, go to people who have been doing these builds for years for race car guys. You know, because a lot of the guys are kind of blue collar. You know, they go out and run the circle track or whatever on the weekends, and they can't have, you know, $50, $60, $100,000 in their cars, or their wives would, well, they wouldn't divorce them, they would just nag at them. Divorce would be a better way to go. So, you know, you guys can't spend tons of money, so everybody understands that. So we're going to go ahead and dismount our current center section and install this one in. The first step of that will be taking the rear brake calipers off. Not a lot to see there. There's a couple of bolts. Take that off because we're going to have to pull the axles just out enough so that they're not located in these holes anymore. And that's what's going to drive the axles of the center section. So I'll go ahead and pop that, and we will give you an update and possibly a report. We'll see how well we can light up underneath the vehicle. Yeah, he didn't put any oil in there.
Actually, I'm going to set it on the scales.
Let's just put it right on the scale. Yeah, since you got it. Let's get a shot of that. It's only 5 pound difference.
Really?
Save very much for $1,100, guys.
Boy, I can't believe that.
I can't either.
That thing looks freaking heavy.
That's solid steel.
The scale was zeroed before we put it down?
Yeah. You can pull it off, shut it down, bring it back up. I weighed myself.
I'll do it real quick. All right, it's zeroed.
We saved 7.5 pounds for $1,120.
Well, we needed a new ring and pinion, and we got a limited slip.
Not necessarily.
This whole weight thing is killing us.
We are back on the Cobra. After conferring with our racing experts,
Yes.
they told us we would save how much weight with our third member change out?
Oh, hundreds of pounds, maybe thousands.
Maybe thousands. They were quite adamant. I love experts.
I think.
I hear from a lot of experts.
I bet.
But we actually asked these guys. Well, no, they suggested this.
They did.
That we could take off a lot of weight getting rid of that old stock third member.
Yep.
And getting us a nice billet aluminum racing third member.
Yeah. Yeah. Swap out that center section.
$1,152.
Yep.
And we picked up how much weight?
7.5 pounds, I believe.
The new one was 63.5 or 0.6.
Yeah, 63.6.
We're in the noise here.
Yeah, that's right.
And the old one was how much?
72 or
71.1.
Yeah, like 7.5 pounds. It's prettier.
It is, and it's not all lost. We have some better bearings, and
we got our 388 gears.
Yeah.
With that, it's a very nice unit, but it was $1,200.
I'm back up front here, You installed the deluxe, beautiful low-car accelerator.
That was a really sweet, real nice installation, and I like that pedal.
And Ryan Baum made us a cable. I had to put the end piece on, which you left off, so you could
so we can get it through the firewall.
The firewall.
Yeah.
We got a little gland nut here for that, and you put me another one here for do some firewall stuff.
Yep.
This is a little Molex connector. All I had to do was shove the pins in the back.
Oh, that's right. He already had them on the wires.
And they kind of catch.
Good.
He had it made up for me. I've never met a connector I like. These are no better.
Okay.
Hopefully they'll make some sort of contact.
Yeah. Hopefully they'll be close.
He, of course, has it upside down on this controller, but you just plug it in and it goes snick. Of course, that one doesn't exactly do that because it's like all connectors.
It's like all connectors.
And so it's partly on there. This controller, which I am actually, if it puts out the stuff, this is pretty good.
This is a nice unit. I mean,
I like the package.
Is pretty good. Yep.
He sends a wiring harness already done that plugs right in here.
Looks good.
Let's see, we've got 2, 4, 6, 8, 10 wires coming out of it, and that's what you have to hook up. This is one of the easier ones we've ever dealt with.
This is not bad.
Not just as you have the connector harness done, but it's just a simple connection. We've got 2 orange wires. They go to either side of our contactor, and it doesn't matter which is which.
Oh, really?
It really doesn't care.
Okay.
This is our pre-charge circuit, and if you notice, I do not have a pre-charge resistor on my contactor.
Well, so there must be one somewhere.
There must be someone somewhere. It's actually better than that. This is pretty well thought out. The controller almost always has some input capacitors to charge to the DC level.
Yeah.
So as it applies this waveform to the output, it doesn't really feed back to the input. Your source is always pretty stable.
Okay.
And they'll be pretty large size capacitors. And they're always there. And so if you just hook it up to your battery pack, you'll get a sudden huge inrush of current into those capacitors, usually blowing any fuses and sometimes the capacitors.
Okay.
From the large pack voltage. So what we typically have to do is put a resistor, typically 500 or 700 ohms, a K ohm's fine. It's not too critical. It's to restrict the current.
Right.
And so with the contactor open, those capacitors charge to your pack voltage, but at a low current level, as is restricted by that resistor.
By that resistor, yeah.
And you typically use a power resistor because it is some current. And then once the caps are charged, you can close the contactor and there's no inrush.
No inrush, yeah.
He's got all that built in. In fact, this is the 2 connections to that. And then the contactor itself is connected to the red wire. And the contactor, the other end of the contactor coil, is connected to ground. And so the controller actually does the pre-charge for itself.
Okay, good.
And then closes the contactor for itself.
When it's ready.
When it's ready.
That's great.
And I like all of that.
That's really good.
The Etics Soliton actually moves the contactor inboard. I have mixed emotions about that. It's nice not to have to
deal with the contactor. As long as you never have to
contactor.
maintain the contactor.
Right.
Right.
I kind of like to have the contactor and the control of the contactor. I've run 2 red wires the length of the car back to our guest emergency shutoff. And so I'll connect this red wire to one of the end of that and the other end to the contactor. And so I can break all this, even with a car running, with that switch.
Through the switch, yeah.
And it not only breaks the pack, hopefully, and we're a little bit above the rating of that switch
Yeah.
at 1400 amps.
Yeah.
But also the aux contacts will break our contactor.
Contactor, yeah.
So it's just kind of a double level.
That's nice.
of
First time
control.
we've done that. That's very nice.
The rest of the inputs are fairly simple. Our yellow wire, it goes to 12 volts,
Okay.
unswitched. Our blue wire goes to our ignition switch, 12 volts.
Okay.
And the green wire goes to a start position or a start
or a
button.
start button, or-
We're either going to have to use a switch with on start or a start button.
Okay.
But both of those are actually a little bit more familiar to people than the way we do it, which is usually set it to on and everybody gets in the car, tries to start it anyway.
Yeah, that's right.
And so this is it. The violet wire is right here, and that goes to our reverse light.
No, okay, on our transmission, sure.
And the black wire, of course, goes to vehicle chassis. And the brown wire goes to our brake light.
Okay.
And I have no idea what this white wire
What the white wire does?
It's kind of hard to draw a white wire. I understand, but I have no idea what the white wire does. Our we're going to have to take a look at that. Yeah, we just don't know what white's about. Like I say, the throttle is all through there. This end, of course, is our B plus and B minus battery.
Right. B plus and B minus.
He
Yeah.
doesn't have this mark, but he swears he's going to on the,
on the case itself?
Yeah.
Yeah.
The battery and motor marks. But B plus and M plus for your motor is on the same bus and so on the same side.
Okay. Okay.
B minus and M minus are actually broken in there, and that's where the switching goes on.
Oh, yeah. Okay.
In the controller.
In the controller, yeah.
And so this is our B plus, which goes to our contactors, or our B minus, which goes to our negative. This then would be our M plus and our M minus. On the motor, we connect A1 and S1 together.
Right.
And we've done this with some 4-aught cable. Was that fun?
That was amazing. Yeah, that's a lot to work with.
We've got some stuff that's particularly sort of a double insulated.
Yeah, it's a pretty cool cable.
And then it's pretty big 4-aught cable. But we managed to get it on here. The terminals on the 11HV are kind of weeny.
They're small.
They're more 5/16 than 3/8.
Yeah, they're actually very small.
And they're little brass things. They're supposed to be field replaceable without taking the motor out. But George tells me, but they're kind of weeny. That's a leftover thing from GE, and he and Warfield Motor are kind of going around about that. They'll eventually get to
some bigger
half-inch
studs. Yeah, some half-inch studs, yeah.
But right now, they're pretty. When we put those 4.0 cables on there, it looks pretty weeny. We kind of polished off the little brass terminals on the motor,
burnished it a little bit,
and scraped a little bit on our terminal lugs for the 4-aught cable. No magic in putting that on. I got some boots that really wouldn't fit over the cable, kind of slid them a little bit and got them worked on there, so we got boots on everything. But our A1 and S1 are shorted together. That connects our field windings to our rotor windings.
Yeah.
And that's a series motor. A2 then goes to B plus. And this one, we kind of curl it underneath because we're coming out front here. It's the second terminal in from the front of the motor.
Yeah, you can't twist or do very much with this 4-aught cable.
Right.
It's,
So we went under our mounting plate, and we're going to kind of have to put a clamp or something, make sure it's out of the aux shaft. But when we went to do the M minus, which goes to S2, S2 is on the bottom in the back. And so we had to bring this cable across the top. Well, I've got this square edge of this aluminum. Now, this is double shielded 4-aught, but you don't set yourself up for that. If you have a cable rubbing on a piece of metal,
of vibration.
just quit that.
Yeah.
You have to have a clamp or something.
Yeah, you got to stand it off.
Isolate that cable or stand it off.
Yeah.
It's a matter of time until you're putting your 1400 amps into your frame.
Into your frame.
And that's not going to be, if nothing else, it'll blow up your controller. So we put actually a gland nut here. Brain was able to get a drill in and cut a hole just big enough for a big gland nut. And we ran it through the plate that way. And of course the gland nut keeps it from sawing on the metal.
On the metal, yeah.
And we had to measure kind of carefully and get this to come out because these 4-aught cables do not twist and bend very much.
Yeah, you got to put the angle. You got to make sure that those lugs are at the right angle to hit that. It's a lot of work. But
and we got that connected. The only remaining connection, so we have this 10-wire thing that's your control inputs for the start and on and the contactor and ground and 12 volts from various places. Your real control, and what a controller does, why we call it a controller, is it takes your accelerator throttle input and converts that to control of your motor. And these series, these DC controllers, some call them a chopper controller, because what they're basically doing is taking your positive voltage from the battery pack and chopping it into a square wave. It simply turns it on for a period and turns it off for a period. I think we're a little over 12 kilohertz on this one.
this one, okay.
So 12,000 times a second, it turns it on and off. Now, if it turned it on where the positive portion was equal to the negative portion, that'd be a 50% square wave, and you get half of your voltage. The motor itself is a big coil, so changes in current, it resists.
Right.
And so I think of it as it can't see much in the way it changes, and at 12.5 kilohertz can't see it at all.
Right.
So it sees an average voltage and current.
Makes sense.
So if you have half the time you're on and half time you're off, you'll see half your pack voltage. 231 volts would put 165 volts in there. And so if it's on 10% of the time, we'd have 23 volts effectively through the controller. And if you're on 100% of the time, we'd get the whole 231. So by varying this pulse width, and that's why we call it pulse width modulation, we're converting that throttle input into a change in the RPM and torque and power in the motor.
In the motor, yeah.
And that's what we want to do. That's what we're wanting to control. And it does so without wasting a whole lot of energy. There's some heat loss through the IGBT in there, but it's not like the old resistive controllers or switch bank controllers. It's much smoother and much more efficient. And this one is looking pretty good.
Looking pretty good.
He specifically suggests, in case you're wondering, that 2-aught would be sufficient on the battery side, 4-aught being optional. But he says you really should consider 4-aught cables on the output to the motor if you're going to use this at full power.
Well, we've got it.
And we're going to.
Yep.
I'm comfortable with a 2-aught because we're going about 8 inches.
Yeah, it's not that far. Yeah.
From
short run.
So it's, again, it is the diameter of the cable, but it's also the length. And on short runs, you can use much lighter cable. Where actually longer runs, as I said, this thing is kind of long and a little bit awkward to mount. It wound up, I thought I could have it on here and have very short runs to the motor, which is what you want. Actually, that's our longest.
To the motor there. Yeah. We've got the heaviest cable.
And the heaviest cable. But it all goes in. It's actually a very simple to connect, except for the white wire, which I still can't see what that's for.
It's written in white?
Well, it's written in white on a white page, probably. Got orange, brown, violet, green, blue, yellow, black, and gray is what he's showing as the throttle input, which is a whole cable assembly. And so I'm not sure what the white wire's about. Well, I tell you what, he doesn't really show it on this diagram. This may be the previous orange, violet, red, yellow, black. He shows, well, it shows 9 wires. Here's a white. Well, that's just not, let me go to his diagram and see. He didn't really have a diagram in the book on this drive is the problem. Again, it's kind of white output to dash indicator.
Oh,
there
okay.
we go.
All right, so we can put a light or something on there, huh, that the there are controllers on.
Blue's ignition on, green's yeah, that's all as I said. Green is ignition start. Red is the main contactor coil. Purple's the reverse input. Brown's the brake input. Yellow is the constant 12-volt unswitched. Black is vehicle chassis ground, your 2 oranges. White output goes to a dash indicator. This simply blinks if you have a fault.
Oh, okay.
And I'm trying to get him to, he has on the top here some LEDs. One of them is a blue LED that flashes when you have a overtemp situation. Now that's going to show up on my interface box. But I suggested to him that for those that don't get it, to put some sort of coating on this dash indicator light where you could tell at least that you were in a thermal situation was why it was limiting the current. Again, a lot of the controllers don't tell you when they're in a limit situation, and so you think the car's working fine because it's driving down the road fine.
Driving, yeah.
You're just missing half the power.
That's right.
Because of your thermal. We have our 2 Army Navy AN fittings.
Right up here.
It's an AN flare. What is that? 37 degrees is why that's different from
I think
a
it
regular
is.
flare?
I think it is. Yeah, I think it's 37.
And we get those from Summit Racing. I really like them. We use some black nylon hose, braided hose, and then components from Summit, a Durali heat exchanger that we'll put up front, and a little fill tank, and of course we use a Prius pump.
Yeah.
Since I bought the pump that Ryan has, and no one can find it.
I know, we can't find the pump.
It's just missing. $260 pump. I can't find it. It'll show up after we get done with the car. We'll use the
It'll be
Prius
under
pump.
something.
And I probably put it in the car somewhere so I wouldn't
lose it.
And that lost it. And so this is, I would say, as the component hookup on the controller is probably the easiest one I've done.
Yeah, I mean that is relatively simple. Yeah, that's nice.
The setup on it is likewise very similar. He's thought through everything where you don't have a lot you can set. You don't calibrate the throttle. You have to use one of the throttles he's already calibrated.
Done,
You can select the throttle on the interface thing, and it's very easy. You're left with 2 CAN bus ports. One of them goes to your interface module, and the other one is essentially you could connect equipment to this and get data from it for other kinds of display or to tie in with other systems. This is supposed to be an industrial controller, and they do sell both the Netgain motors and this to some OEMs, notably Zamboni. The ice guys buy a bunch of motors, and so George sells some motors some other places. He's a big percentage of Warfield's output now.
Really? Wow.
And so
well, they should love him.
Yeah, they do, and we do. And apparently most of the EV guys do too. Bang for the buck, kilowatt hours. I mean, we like the AC systems. I like that high performance electric vehicle systems. But we're at 75 kilowatt on that. In the Mini Cooper, I've got a 30 kilowatt motor and a 100 kilowatt controller. And we had a, what, about 130 kilowatt controller before.
Yep.
And all that works great, except I need 250,000 watts.
Yeah.
And your bang for your buck on that always gets you back to a series DC motor. Okay, I have to change the brushes every 100,000 miles. Duh.
Yeah. Oh well.
They're $100, and
yeah.
You know, I mean, it's people keep decrying that series motor. The reason it's so powerful for the dollar is because both the field windings and the rotor windings get the full current.
The full current. Yep.
And they're interacting with each other. All the other kind of motor, AC motor, you're actually inducing a secondary current in the rotor. Right. It's not as strong as the as if it had current
if you were flowing through current.
The neodymium magnet motors are quite strong because the magnets have got to be pretty strong, but not as strong as they'd be if they had current through them. And so you're never going to get the torque out of those motors that you do out of a series DC motor.
Yeah.
There's a lot of efforts now to make motors that are smaller and lighter. The Evo and the Yasa spring to mind. Ramey, that motor's kind of becoming available to EV guys. And I like all that, and it's sexy. And let me tell you something about motors. You are harnessing the power of a magnet, and the magnetism comes from the flux from a passing current. The mass of this motor, the iron in the case, counts. And the properly designed motors, this flux is at maximum saturation. In other words, if you put any more in, it's not going to produce any more.
Do anything else.
Because you do not have the mass of that iron to channel it.
Yeah.
And so when you look at a big, heavy forklift motor and decry it, we've had electric forklifts for 100 years. None of this happened by accident. It had the same Darwinian evolution that the automobile did.
Right.
And there's a reason why it's a big, heavy motor. It's true that it's okay to be heavy in a forklift.
Forklift's fine, yeah.
But when you have that luxury, that mass of iron actually counts in developing the field that drives this motor. The force we're using here is the magnetism of two opposing current fields.
Yep, two opposing fields, yeah.
And that's the mass of the motor. All motors properly designed, part of their limitation is simply if you put more current beyond that, it doesn't have enough ferrous mass to make very good use of it. It starts just becoming heat and hysteresis. And so having a big iron case seems like a big disadvantage for an EV. Well, unless you want it to go fast.
Right, unless you want power.
If you want power, you're not going to do that with a Ramey.
With a light motor,
or an Evo. That dog in hunting, what they're doing in most of those is they put in two of them.
Yeah,
well, that sort of negates,
you're back to the weight.
The process of it being light.
Yeah.
If you're using two of them, that's so these are just some background factors to consider, and that's why a series DC motor is my choice for an application like this. Now, for my drive around car, both the Mini and the Speedster I like the lightweight AC induction, 75 or 100 kilowatts, and good gearing, and make it light and sprightly, and
you're off.
And I'm off like a herd of turtles.
Yep. That's how he drives.
This Cobra culture, as described to me by Brian, is geometric. That is, whatever size the car in the rear view mirror is now, very quickly it should look much smaller.
Much smaller, that's right.
Well, I know how to do that. I don't know why to do that, but I do know how.
We know how to do that.
And I think this 11HV and this Warp-Drive Industrial may be very good. I got a question today on the blog. Why didn't I just use a Zilla 2K?
We have one.
Oh, I've got one.
Yeah, we've got one.
You don't have one, and I'm not sure how you get one.
Yeah, we're not. Right.
I've watched Otmar and the Zilla die for 3 years now, and it gets down on the floor and thrashes around, and it never does quite go away, but you really can't get them either. I got mine on eBay.
Right. Yeah. Yeah. We just can't show stuff that you can't get.
And what's the point of me designing a drivetrain and showing it to you on the TV if you can't get the components?
Right.
Now, I understand Rich is doing something and they're going to have it available through Manzanita sometime, somehow.
Yeah. And maybe they will, but not right now.
Well, you know, both of them are kind of mad at me because I don't sing their party line on the battery management system thing. And so it's hard to get information out of them. It's they're difficult to deal with, and I don't need the cranial damage of all that. But I've got a Z2K laying around. It's at this point kind of an older technology. I'm engaged with the new stuff with newer components, IGBTs from that Etics are using, and Ryan's using with this, and they're just they're better because they're newer components and newer designs.
Yep, the technology is newer.
But as far as the hairball and all that, this is much cleaner, easier, and cleaner and easier is a sign of durable.
Yeah, right. Just less stuff to deal with.
Right. Whenever you have something complicated, that's not a good sign that it'll last.
Yeah.
It doesn't mean that complicated things can't be engineered to last, but usually it's a sign that it wouldn't.
There's just more stuff to go wrong. Yeah.
And so, all other things being equal, simpler is better.
Yeah.
Watkins razor. The simplest solution, evident, is probably the correct one.
Probably the good one. That's right.
So yeah, here's our CAN bus. I think CAN bus is going to be the rage in the future. I think the displays are going to go that way, and we're going to wind up operating with CAN bus. Here's our cooling ports. We still have to do the cooling system. I need to wire up 10 wires, and yes, white is for LED on the dash.
Okay.
Actually, you can use it with a bulb up to 2.5 watts, we'll probably get some trick-looking LED to hook it up to and shove it right through here to our dashboard, and we'll be cool.
Okay.
And so that's the progress on the Cobra. We're getting fairly close.
Yeah, it's getting there. Yeah, we ordered the drive shaft because now that the rear end is done.
12.25 inches.
Yep, in this application, 12.25 inches. That Ford rear end was a 1310 U-joint back there, which I didn't have the slightest idea of until yesterday.
Now you know.
Now I know. So what kind of end you got on that rear end of yours? Huh? What do you mean?
What's the yoke on our transmission?
That's a 1 1/16 the yoke, and so is that rear end, but it has a name and a number that they need. It's a 1310.
Both of them?
Yes.
Good.
And we got the little U-bolts for it and everything, so we'll be good. So we're all learning things.
So we've got that on camera now. I can come back and find that number if I need it.
Yep. Yeah, 1310.
1310. 12.25 inches.
That was the address of the first house that I
Some
remember living in.
things we tell you is really not for you, so I can go find it later.
That was the first house
I can't find
in.
the piece of paper I wrote it on.
It's 1310. I'll remember that one.
And so we're coming along. We got the brake system we have to reassemble with our, George talked me into a, what do you call it? Where you stomp on the brakes and it...
we got a line lock.
A line lock.
Yeah, we've got a...
So we can lock the front brakes and make the rear tires smoke and squeal.
Yeah.
Why did we do that? Why did he want me to do that?
It's just nice to show tire smoke.
People like tire smoke.
And it'll also work as an emergency brake.
You know, I hadn't thought about that, but it would.
Yeah, it makes a good emergency brake.
You could just put on the brakes.
Yeah.
Lock it on. We'll tie that into unswitched 12 volts and a switch where you can just turn off the car and leave that locked
and leave
up.
It on.
And
yeah, just leave the lock on.
Parking brake.
Yep.
Excellent. And, we've got our excess turbo.
Oh, yeah.
This is a little Garrett turbocharger, but they pull the turbo part off, put this little electric motor. This thing does 450 cubic feet per minute, and I've got a collar on it. It slides right down there in position. I had to turn it around from where I had originally had it, but it fits right in there.
Fits good, looks good.
We had a couple conversations about that. It's not when the motor's going big that you need it.
Right.
The motor has a fan in it. If you get it up to 3,000 RPM, it's got great airflow.
Yeah. Yeah.
It cools itself just fine. When George was out here, I took him out in the Speedster, and I stopped at a stoplight on a hill and held it there with the accelerator. He almost had a heart attack. What are you doing to my motor? Just sitting there running current through it, George. It's not even turning. It's not breathing hard at all. Oh my God! Because you see, there's no moving air.
Yeah, there's no airflow through it. Yep.
And so he doesn't like that. This moves the air. I'm convinced, and have reports from actually Sebastian at Etics, after they've blown up a half a dozen motors, that blowers are cool.
Yeah.
And this one, we've looked at a lot of them. They tend to be a couple hundred cubic feet per minute. Very loud,
yeah,
high
a lot of
speed.
them are really loud.
They're really loud because they're kind of high speed, even to do that 200, and pretty good amperage. This Garrett thing, he's got a motor on here. It doesn't draw much.
Yeah, no, it doesn't.
And it doesn't make that much noise. No. I mean, it's audible, but
but it wasn't bad. No.
For twice the flow, it's half the noise.
Yeah.
And so I kind of like it.
And it looks pretty cool.
And it looks cool.
Yeah, we got a turbocharged electric motor.
I've got a turbocharged electric motor. That's exactly right. That's what I always wanted.
That's it.
And so that's our status on the Cobra. Paul Lynn will be here. Talking at the convention. I think Brian from B&B is coming.
Oh, good.
And so we should, we're going to get a report on EVs in Asia. And most importantly, what's he going to do with an electric Cobra in Taiwan?
In Taiwan, that's right. Please tell us, Mr. Wizard.
And so that should be a good time. We should have this rolling, I hope, by the convention. But it's
moving along.
What's today, the 8th, 9th?
9th.
21st.
Yeah.
We got to get smoking on that dash and brakes.
Yeah. Yeah, well, the next thing will be the hydraulic system. The brakes and the clutch.
Oh, that's right.
Netgain Motors, home of the Warp, Trans-Warp, and Impulse motors, introduced the improved Warp 9 motor. The Warp 9 is a 9 1/4 diameter series wound DC motor with a double-ended shaft featuring 26 improvements for 2010. Externally, the terminal studs have been enlarged from 3/8 to 1/2 inch diameter. Bigger is better. On the inside, a larger commutator, new brush composition, and split brush design with heavier springs handle even higher voltages and currents than before. Our new fan increases airflow by almost 50% over typical paddle-style fans. And all this translates into improved performance. For even more performance or larger applications, take a look at Netgain's Warp 11 motor. An 11 3/4 diameter series wound DC motor for even greater torque and power. Since 2002, Netgain Motors has been leading the EV industry with precision, performance, and price. Visit us at go-ev.com. Netgain Motors, warp power to go.
All right. We have done this wiring that we were talking about. Put a little bit of wire loom, this plastic wire loom. It's pennies per foot. Some spot tie. It just kind of make our wiring a little bit nicer. I did want to mention our contactors. This controller is unique. It has a diode in it that's meant to be a pulse suppression diode for the coil of your contactor. There's a problem with this, and I've identified it to Ryan. He's going to make it a jumperable item or something in the future. The Anderson type contactors, the open contactors, this diode prevents a voltage spike when you turn off the 12 volt to the coil. The coil, which runs the contactor, will try to induce continuation of the current, and that causes a big voltage spike. This is bad news on your 12 volt system. for other materials. And so they typically use a voltage suppression, spike suppression diode. Some call it a snubber diode. And many of the old EV hands are very taken with this concept and recommend its use. Tyco Kilovac, the type of high current relay that we call a contactor, it's not precisely a contactor, it's a high current relay, are enclosed. And they've actually issued a white paper asking you not to use a spike suppression diode because it lengthens the open and closing time on the relay and derates the amount of current that it can make or break. And so you don't actually want one of those diodes. This controller has it hardwired into the controller. And that's a little bit of a problem, particularly at 1400 amps. We've identified this to Ryan Bohm. He's going to address it with some sort of configuration type thing. I also wanted to talk a little bit about a material we have this mounted to. Now, of course, we painted it black so it disappears. You can't see it. But this is a aircraft aluminum honeycomb panel that I found on eBay, and I'm just absolutely taken with this. It's quite stiff, half-inch panel, but it weighs nothing. It actually has a negative weight. If I let it go, it'll float up. This is an anti-gravity weight on this thing. It's super light, but super stiff. And so we made a little shelf here over the motor running from the transmission to our front plate out of this honeycomb material, and I wanted to mention it. That is, we're going to find all kinds of uses for this because it's extremely structurally stiff, but it's lighter than actually some of our 80 or 100 aluminum sheet. It's a very thin cover, but then it has a very thin aluminum foil honeycomb between it, and it just makes a really stiff, light material. You can drill through it. It'll hold a screw. It's actually a fantastic building material for electric vehicles. I could see doing a body out of this. I don't know how you'd bend it, but it's aircraft aluminum honeycomb, and we found it on eBay, and it was you know, they weren't giving it away, but it was reasonable. And so we used that. So again, we've used wire loom to clean up our wiring, routed a bunch of it in under the thing over to our DC to DC converter outputs. Our two orange wires on the contactor. Our red ones actually go through our switch back here. And for the contactors, that's an extra long wire. We're pumping that through with that suppression diode. I don't know what to think about all that. But the final thing is I've wired up our little pump here. This is our Garrett turbocharger. And I'm going to let you see the sound it makes, which I wouldn't want to talk over, but it's not too bad. And with the hood closed, I don't think it's going to amount to anything. And there it is. You can feel good flow through the motor. And I had a ammeter here a minute ago. I don't know what I've done with it. We measured 2.5 amps continuously at 13.75 volts, 35, 40 watts. It's moved 450 cubic feet per minute. I've seen it, he's claimed 435 and 450, but that's pretty close to the same thing. It sticks on our little collar quite securely. It's relatively quiet, uses a reasonably low amount of power, and we get great airflow. I've got great airflow through this motor right now, and it's sitting here dead in the water. So it's kind of a neat little thing, and they're very proud of them at $375. It's at xsturbos.com, but we're using them to cool these DC series motors pretty successfully. We're getting closer. We have to tie up our transmission input. our brake light input, and our ignition switch, which we don't really have an ignition switch for this car yet, but we're going to get one. And I'm trying to find something, you know, like from a 57 Buick Roadmaster or something, you know, something like that. And we'll wire up an ignition switch, and this controller will actually be ready to test and hook up to our interface box. That's just an ordinary Cat5 Ethernet cable, RJ45 ends. You've got a little weatherproof cap here to deal with, but it's trivial. And so we'll hook that up here to our interface, and should be able to talk to our controller and maybe even make the motor turn a little bit. Right now, it won't do a whole lot of good. We'll have a little bit of a load on it with the clutch and the transmission, but that's not really sufficient to guard that motor, and particularly in the case of some sort of uncontrolled event. So I need a 12¼ inch drive shaft to really test this thing. We'll jack up the back wheels where it's turning those and put it through its paces. Brain, are we ever going to finish this goddamn car?
Yeah, eventually. It's not like we're not trying to. It's an interesting project. I mean,
this thing has got me in the floor fighting with me.
Yeah,
it's actually coming together pretty quick now.
It's moving along pretty good now.
Those battery boxes were a nightmare. I actually have built an electric car and have 2 chargers on the way, and I don't know that there's a place in the car for either one.
I know. Passenger seat.
Yeah, she may have to carry the damn charger.
That's right. Just here, honey. Put this on your lap. Sit on this.
Yeah, it's J1772.
It'll keep you warm.
You'll love it.
It'll keep you warm.
I don't know where we're going to put it,
Yeah,
but the controller's coming along.
Mm-hmm.
You're working on the hydraulics.
Yeah, we're doing the hydraulics. Yep.
Revisit the cooling system, but I almost count one of the few remaining places on the car where a charger might go is in the front, where I was going to put our Durali.
Mm-hmm.
And I think it would fit there. I don't think we can get it there.
Oh, get it in there. Actually physically get it in. Yeah, because those chargers are pretty big.
Yes.
Yeah.
The Elcon I've got on order is pretty big.
Those are usually pretty big.
We have a blown up PFC 30 that they're supposed to fix for us. That is a little smaller.
Yeah.
And would do this. The problem is we got a 41 kilowatt pack. We need a pretty good charger.
Yeah. Yeah.
To pump that up.
Yeah.
And so that's that. So this thing, and we are, what is today? Since it isn't Friday, what date is it?
Today's the 10th. 10th of September.
We were 11 days from the conversion.
Yes, 11 days from the conversion convention, absolutely.
And I don't know how we'll be able to get this thing done. Oh, in my description last week of our speakers, I forgot my main guy. He's going to be the best speaker there. I happen to have had several little birdies tell me. Eric Chris.
Mm-hmm. Yeah.
This guy has been with several venture capital firms, started several health companies, worked for Mitt Romney in Massachusetts on the state budget. I mean, he's a Renaissance guy. He's all over the place. He's done a Factory 5 Cobra.
Right.
And now he's done a Speedster. Duh.
Yeah.
And he's going to come speak on a variety of things. He sends me little white papers all the time. The latest one was kind of a energy analysis, sort of like my Speedster Spider thing, but including the wall losses and so forth from the outlet to the all the way into the batteries and back out. And but also on the Chinese battery manufacturers and so forth. Cool. He's a very very bright guy, and I'm told actually quite a speaker. And he teaches at the University of Miami or something.
Yeah, I think he's at the University of Miami. Yeah. And
so he will be speaking at the convention, and I got the show guide done.
Show guide's out.
With our itinerary, a description of the speakers. But I also got little photos and stuff. This was something Chris had put up on the website. We contacted all the people who took the 595 thing.
Yeah.
And that's closed, by the way, because the book's sent off to the printer.
Yeah, it's over. just the $5.95, not the registration.
Yeah, you can get it for $595.
There
You
you
can't
go.
for
Different
$5.95. We've got all the car, but he set up a thing where they would come in and upload a photo and some info about their car, kind of EV album style. And I've got that in the show guide.
Yeah, show
for the
guide
cars
is looking
that are
good.
coming. And so it's off to the printer. I hope it's back by the 21st in 4 glorious colors.
Yeah.
And, so there's that. We Chris has been helping us actually with Chris, in the Navy. You were an ET.
Yes.
I happen to know what that is, but would you describe what an ET in the Navy is?
It's a rating designation for electronics technician, and my particular specialty was communications, satellite communications.
Okay.
But it could be radar or line of sight communications.
They wanted me to be an ET nuke when I went into the Navy in 1973. Yeah, 73.
You know, I was born in 1973.
Were you?
Yeah.
Yeah. Well, that year nuclear was huge.
It was huge.
Yeah, that was big.
And they wanted
Nuclear.
to be an ET nuke, but that was all submarines in those days. There was like one aircraft carrier, but all it was submarines. And a guy I knew who'd been in the Navy said, Jack, they have an old saying, what goes up must come down. But the submarine guys, they don't have any of those sayings. I said, like, what goes down doesn't necessarily have to come back up.
Yeah, kind of.
Okay, I took the hint and went into, I became an Airedale.
There you go.
And I was an AQ. But, so an ET works on electronic equipment and so forth. So he's kind of wanting to get into EV conversions, but you hadn't actually driven an electric car.
No, I haven't. I haven't done that yet. It's I'm looking forward to it. Maybe you'll let me drive one of your cars.
Let's go fix that.
All right.
Well, I don't know if we got any video of that or not. We've got these little cameras. He's
Playing
got
with
a
some new
Go, and I've got a Contour, and they'll do everything but shoot video,
video.
When you want them to
That's
shoot
right.
video.
You'll just find them laying around on. Yeah.
They, as long as you're testing with them and playing with them, they work pretty good. But we kind of struggled getting them to actually work and catch them in the act of working in real time.
On purpose. Yeah.
On purpose. So what do you think?
Well, you know, it's not a gasoline car, and it's
No, it's not. Doesn't
it's so
feel like a
smooth.
gasoline
No, it
car.
doesn't. And the shifting is something that's just a slight bit different because you don't have the static RPM of the idling engine, but that was quickly, easy to get used to.
It is different.
It is
and
different.
you do have to adjust to it.
And it was so smooth.
But all of a sudden you realize, hey, I'm driving an electric car.
And I did, I had to kind of really pay attention to not keep my foot on the clutch when we weren't moving, It was natural for a long time. But I didn't even have to think. It's like an automatic car almost, just driving.
Yeah, I call it kind of selectomatic, and I've got this one with a bunch of regen in it. We're doing some regen testing. It was the worst possible setup for him to be introduced to an electric car, and but he was well able to handle it. His description of it was moments for him to sort all this out, and so it's
it was. I'm ready to buy it. So
it's an exhilarating acceleration.
It is.
Yeah.
Yeah.
How do we? That is the mission. I truly believe that to know these cars is to want one.
Just have to get in one.
And this has to be done from the demand side. Obama can mandate 54.5 miles per gallon. All the manufacturers can go into a frenzy of making electric cars. If people do not buy them because the value proposition is poor, and continue to want and desire Yukons and Denali's and Escalades, this is a no-show.
Yeah.
Nissan has put a $5.6 billion bet down. This Carlos Ghosn is, in some ways, a genius to see this clearly and to commit that kind of resource to it.
Yeah, serious.
But how can it come out? It's
sell a lot of cars.
It would take a lot of years to build from what they have right now to the 150,000 a year he needs to get that investment
to fix
back.
that.
He would have to sell 173,000 Leafs to get his 5.6 billion back gross. That's not profit. It's if the cars cost him nothing to produce.
Right. And they're probably expensive to produce right now.
And so it needs to be driven by the demand side, and that's what I think the mission before us is, to, at the grassroots level, get a lot of people buying and building and converting electric cars, and to carry that message to their neighbors and friends and so forth. And at some point we'll reach a tipping point in that perception. A man sent me an email today about a guy he characterized as a really smart guy, a noted photographer with a blog, and he had piled more nonsense into one paragraph about electric cars than anything I've ever read. It says it would take 4 times the electric plant to be able to charge the cars, which all charge from 460 volt 3-phase.
Is that how you charge your car?
No, none of them charge that way, and you don't need 4 times the plant. None of the, they don't have the horsepower. There's a reason cars need 300 horsepower, and you can't run a car on 20 horsepower. And it doesn't understand the relationship of horsepower, RPM, torque, any of it.
Yeah.
It's just a comical compilation of misinformation. But it represents the body politic in extremists, and you have a milder version of that throughout the public and their perception and understanding of electric cars. I can take people who, Chris has been watching our show, I know for a year because that's how long he's been doing the index for.
Yeah, that's right.
Probably
he's been working diligently,
that, and but still, it doesn't make the trip until you put the seat into the seat.
Right, right.
I wanted to do it, but I had no idea. And there's no way I could figure it out without actually doing it.
Well, you've seen us describe it. Did we get the message across and what you felt today?
Yes, what you say is absolutely 100% accurate.
But you never did feel it.
You can't feel it.
I believed you.
You believe you believe
You
me.
believe us.
You couldn't.
But I had no reference.
Right. There is
Other
no
than the golf
reference.
cart.
Right, right.
And other than the golf cart, our experience revolves around, and electric transportation revolves around golf carts and elevators, neither of which would make a good replacement for an automobile.
No, not really. Very short trip.
Yeah.
The other element that is frustrating is that we've been making electric cars for 100 years. And we've had people in this thing, the Nedra guys and so forth, for 30 years, doing modern conversions. These batteries are 3 years old.
Yeah, we couldn't get them until 3 years ago.
I'm not down on lead because I don't like lead guys, or that I don't like electric cars. I'm down on lead because it gives the wrong impression. There has been a sea change in electric transportation based on one thing.
Yeah.
A battery.
The battery, the lithium-ion
Chris was
batteries.
looking at my 1913 Cushing and Smith electric car guide the other day.
Oh, okay, yeah.
And I noted that, hey, these guys really cover this in quite detail. I said, yeah, they also predict that we'll have the good batteries
battery breakthrough,
in about another 6 months.
Yeah,
that
that's
was
right.
in 1913.
Yeah.
Still waiting.
If you're so used to waiting, you miss that it came.
Right.
2008, these cells became available to me and to my knowledge.
Right when we got them, yeah.
For money.
Yeah.
You have to do a wire transfer. You have to wait 16 weeks. in those days. This
That's
is
right, we
getting a
did.
little better
Yeah,
now.
it's getting a little better, but that's what we
you
did.
you had to do a wire transfer to a strange place in China, and 16 weeks later, a strange crate showed up in the driveway. And they were batteries that you knew nothing about, and by the way, the spec sheet wasn't much help.
Right. Yeah.
And we've had to learn about them from scratch since then.
Yep. Yep.
That's
Absolutely.
the game changer. That's when it arrived.
Yep. Yeah, that's when the clock started. Yeah.
We did our video in May of 2009. The car was rolling Christmas Day.
Yeah. Yep.
And we'd been testing batteries all the previous year in the
we have.
gyms and so forth. And that was the date certain of the change. And it's not the same. And I'm sorry, a lead acid car is not anything. It shares nothing with these cars. There's no aspect of it. A lumbering wagon with 1,200 pounds of lead in it is not a car. It's a science project.
It's a demonstration.
That it can go 20 miles and everyone will claim 60 miles downhill because of the weight of the lead.
Yeah.
If you don't turn on the ignition key, it might go 60 miles. And the second time you charge it, you get less.
Yeah.
And in 2.5 years, you get to buy them all over again. That's not an electric car. It's not a viable automobile. And people know this and have some familiarity with it. So when I come to them and say, hey, have you heard about an electric car? Oh, yeah, I know all about them. They don't work.
Right. Yeah.
Well, we're talking about two different
That's right.
things.
Didn't work. Yeah.
And the difference is the battery cells.
Yep.
And I see them getting better at a regular rate of about 8% a year. And subject to, what would you call it, disruptive technology introductions.
Yeah, in the battery industry.
The problem with investing a lot of money in the battery industry is we're at a point where someone can simply announce something and you're done.
Yeah, just turn it all upside down.
And
that's good.
So it's going to be a frontier, rough and tumble, Wild West style industry for 20 years, or maybe
there's
30.
going to be money to be made. Yeah.
It's Dodge City, 1886.
Yep.
Bring your 6-gun. Hope Marshall Dillon shows up.
High noon.
High noon. It is.
Yeah.
And it's going to be a wild ride. But it starts in 2008, and it's different now. And you can build cars that they work like cars.
Yeah. Drive like cars.
Drive up and down the highway till your butt's sore.
Yes, happened to us.
Ask me how I know.
That's right. Yeah, sore butt.
I'm Jack Rickard for EVTV.
And I'm Brian Noto.
We'll see you all next week.